what you're going to be doing for the next few weeks is we'll be working a little bit further into functions of different types and graphs and stuff. Okay, so what we're going to do on this is I've given you a piecewise function. I've given you a graph. Your job is to give what the equation is, okay? All right? So watch this carefully because a lot of students struggle with this, okay? Here's the idea. There are two pieces to this graph. Okay, so when you write a piecewise function, you put it together like this. You just say f of x, then usually you just put a parenthesis like that. And you got to do this. You got to figure out the inequality and you got to figure out the function. Okay, so this first piece right here looks like it's going to go from -4 to 0. Okay, it's going to be between -4 and 0. So the condition you're going to say is -4 less than or equal to x less than or equal to 0. Now the reason I do less than or equal to is because you have solid dots there. If you had an open dot, you wouldn't put the equal to. So that's how that goes. Okay, the second piece is going to go like this. It's going to go from 0 to 3. So we say 0 less than or equal to x. And then we say less than or equal to 3 like that. Now, one of these has to be less than or equal to. So this one right here, I'll talk about that in just a minute. That probably needs to be less than, but we'll look at that in just a minute. You can't have both of them that way on that problem. One of those places right there has got to be less than or equal. The other one's got to be less than. Okay, now watch this carefully. So this is a line, right? What's the general form of a line? What's the one you know? Y equals mx plus b, right? Okay, so this first line, we got y equals mx plus b. Okay, and if you look at this one I highlighted in yellow, what's the y-intercept of that line? 0. Now, let's look what the slope is. It looks like you're going down 2 over 4 is what I'm seeing, okay? And you can do it a different way. It looks like down 2, right 4. So what I'm getting from that then is that's going to be 0. And then again, that's down 2, right 4, so that slope is going to be -2 fourths x plus 0. Okay? However, that's going to reduce to y equals -1/2 x. Okay, so what you do is you put a -1/2 x there, and that gives you what that equation is then. Okay? So on these problems, I'm typically looking at lines so that you can get the equation of that line. Okay, does that make sense to everybody? Okay? Now let's look at the one that I have in blue. Okay, so it looks like on that, again, we have y equals mx plus b. Same idea. Okay, what's the y-intercept of this graph? 0. What's the slope? It looks like 1, 2, 3 up, 1, 2, 3 over. So it looks like 3 over 3, and you can reduce that. Okay, so that one's going to give 0 there, and then 3 over 3 there. So you're going to end up getting y equals x plus 0 or just y equals x. So you put that right there. So that's your piecewise function right there. Now, one of the things happens on this one is they connect, so it doesn't really matter which one of these things you had a less than or equal to and a less than on. Wouldn't make any difference. But what happens on this is if I plug in 0, if I plug in 0 to -1/2 x, that gives 0, doesn't it? If I plug 0 into x, that just gives 0. That's why they connect. So it doesn't really matter which one's less than and which one's less than or equal. You can't tell from the graph because that was a solid dot, but it was that way because it connected. Okay, you guys understand how I figured that out? Okay, you got lines, so it's y equals mx plus b. Is that how you're going to put that together? Okay, let's do one more of these, and then I want to do an application of a piecewise function. Okay, so this second one, number 24, okay, we write this like this. Okay, so first thing is let's look at this, okay, and put that together. Okay, where would you go from? Where to where on your condition? Where's that going to be? What to what? 0 to 3, right? Okay, that's 0. That x value is 3. So we're going to say 0 less than or equal to x, less than or equal to because it's solid. How about the next one? Would you say less than or equal to 3 or just less than 3? Less than or equal to, because it's solid. Okay, that's important. Okay, that's a little picky detail you got to pay attention to. So we have that. Okay, how's the next one going to go? That looks like what, 3 to 5, right? That one's open, that one's closed. So this one is going to go like this, okay? What you're going to say is you're going to say 3 less than x, and then less than or equal to 5 like that. Does that make sense why I do the less than there? That's a bubble. That doesn't include that, but that is included because at the 5, that's a solid dot, okay? Now, we did basically the same thing with our equation. So this first line, we have y equals mx plus b, the one I highlighted in yellow. The y-intercept on that is clearly 1. The slope is 1, 2, 3 up and 1, 2, 3 over. So that looks like y equals 3/3 x plus 1, okay? You simplify that, you're going to get the equation x plus 1, okay? So that's how that works. Okay, the second one, when you do this line, again, you're going to have y equals mx plus b. Okay, so what we're going to have with this then is the y-intercept. You can't really tell that until you count out the slope. So let's do the slope first. So if I do the slope on this one, it looks like up 1 over 2 is what I'm seeing. Okay, now what I want to do is I want to figure out what that y-intercept is, and I'll zoom on this a little bit so you can see this a little better. Okay, so what I'm going to do is if that slope is 1/2, the opposite of that would be to go down 1 and left 2. So from this point, what I'm going to do is I'm just going to go down 1, left 2, and I'll have a dot there. Then I go down 1, left 2, and I have a dot like that. So that thing looks like it has a y-intercept of 1/2 there. Now there is a way to figure that out perfectly, which is what I'm going to do next here, okay? So it looks like that's going to be 1/2, but I don't want to go by looks. That's 1/2 question mark, okay? So here's what I would do. Right, what I would do on this second line is I would do this. Okay, I've already got the information right here. I have y equals 1/2 x plus b. Now I can take either point and plug it in to find b perfectly. So I'm going to take this 5/3. Y is 3, so I plug it in. Okay, x is 5, so I plug that in. Okay, then I go through and solve that equation for b. And it would work if you plug the other point in too. So that's 3 is equal to 5 over 2 plus b. Subtract 5/2 from both sides. You're going to have 3 minus 5/2 equals b. You put that over 1. You get a common denominator by multiplying by 2 over 2. That's going to be 6/2 minus 5/2. So that is 1/2. Okay, that's what I thought it was, but that proves that it's 1/2. So that means then that this second piece on your piecewise function, we just write that as 1/2 x. That was the slope we counted. Now we got the y-intercept. So that would be the answer to your piecewise function. You're just doing everything in reverse. That's a good exercise to give students to do to make sure that you can get an equation from the graph. All right, so everybody understand that okay? Okay, any questions? Okay. All right, now I'm going to do one more example of this one, and this is a real good application. Like if a student's like in computer science or something, and you're writing programs and stuff for business, well, you got to know mathematical relationships on this. So this is a piecewise function, and a lot of cellular phone plans, television plans might work in a piecewise function. Okay, I know tax rates work basically, since there's different rates for different incomes. It's a piecewise function basically. So the idea with this is we're going to try to write a piecewise function out of this. Now the first thing I'm going to do is we want to work out these two problems before we even think about the piecewise function. So the piecewise function makes you think a little bit on this problem, so it's pretty good. And you'll see one kind of like this on your homework. So what this problem says is your basic service, that includes 100 minutes of call, is going to be $20 a month. So here's what that means to me. Okay, if I don't call at all, how much does it cost? $20. Okay, if I talk 50 minutes, how much does it cost? $20, right? If I talk 100 minutes, how much does it cost? $20. That's a flat fee, right? Okay, that's what that is. So basically the answer to this first problem, we need to think about that. So now we go into the second 100 minutes of calls. Well, then it would just be 0.075 per minute after that 100. Okay, so if you had 200 minutes, this is how you would figure out your bill, and this will help you figure out the piecewise function. The first thing is that it'd be $20, right? Okay. Then it would be 75 cents times what?
100.
Times 100, right? Okay, because you've done 100 minutes of calls after the 100, right? So that's what you're getting billed for. Okay, the way mathematically that you would do this is you would have, okay, that's 200 minus 100. Okay, now I want to have you write it down that way because we're going to try eventually to change this thing into a function in terms of x. So if I went through and then crunched this out, I'll just go ahead and just do this on my calculator and see what that fee would be then. So that would be your $20 flat fee, and then plus 0.075 times the 100 left over. So that means the answer to this first one would be, that's going to cost you $27.50. Okay, that's how that goes. Okay, does that make sense to everybody? Okay, flat fee, and then 100 more. Okay, now let's go to 250 and see how this works then. Okay, so if we go to 250 minutes, then it's going to go like this. Okay, well, first of all, what's going to happen on this is it is $20 because you've already you already have your flat fee for the first 100. Okay, then what it's going to be is it's going to be this. The next 100, this would be the second 100, would be the same as what I just did. It would be 0.075, and then what you would do is for this one, you've already done that complete amount of talking there, so that would still be 200 minus 100 like that. So you're just still doing on that, you're doing 20 plus 0.075 times 100. But what you have now is you have the leftover $50, right? What does it say about once you get past 200? That starts costing 10 cents, right? So now what you would have is you would have 10 cents times that leftover 50. Okay, now that leftover 50 could be found by doing 250 minus 200, kind of like that. Okay, now what I'm going to do is I'm going to crunch this out on my calculator. So I've got the $20 flat fee, then I've got the 0.075 times the next 100. Okay, like that. That would be the cost of your 200 minutes right there, right? Does everybody understand that? Okay. Now what you would do is you'd do 50, you have your extra 50, and you would multiply that by 0.10, and if you did that, you would have 32.5. So the answer to this problem would be $32.50 like that. Okay, now that's the easiest part of the problem. The harder part of the problem is trying to put this together in a piecewise function. Okay, so we're going to kind of think about that and see if we can get this put together. Okay, this takes a little bit of thinking. All right, so what I'm going to do with this is let's start by just how you do any piecewise function. You have f of x, then you have a bracket like that. This has 3 pieces to it, right? And x is just going to be the number of minutes that you talk on the phone. Okay, that's our variable. That's what's changing. Okay. All right, let's do the first piece. The first piece is extremely easy. What would that be? What's the problem say? $20, right? Okay, so it would just be this. It would be $20, but what would be the condition? Okay, this is for the first 100 minutes of call, right? So you would say x is less than or equal to 100. Okay, that's it. So what that is saying is anywhere, and you'd also have to have the 0 in there. There's one other thing you want to put in here, so let me do this. Okay, you would say 0 less than or equal to x less than or equal to 100. Okay, and the reason about that is if you don't talk at all, okay, it still costs $20, right? Okay, if you talk 100, it's still $20, so that is equal to right there. It has to be like that. You got to pay attention to the details. Okay. Now, let's go to the next thing here, and let's see if we can kind of piece this together now. So if you were going to go to the next 100, the next piece would go like this. You would say 100 less than x less than or equal to 200. So now we're talking about the second group of 100 minutes, like this. Okay, and this is where it gets a little tricky on this second one like this. So I'm going to erase that, and I'm just going to use this kind of as a model. Okay, so when you're past your first 100 minutes, what does it do? It costs $20 for the first 100, right? So it goes like that. Okay, then it says it's 0.075 multiplied by however many things you have past 100. Okay? So this would go like this basically. What you would have to do on this is, okay, for instance, if you talked for, say that you were talking for 150 minutes. Well, you wouldn't put 150 there, you would put 50 there, right? Okay? If you talked for 120 minutes, you wouldn't put 50 there, you'd put 20 there. So you got to figure out how would you calculate to get that 20. Well, what works on this basically is this, and this is kind of what I was trying to show you on the previous part of this problem. Okay, so it would work basically like this then. Let me fix that thing real quick. Okay, so what you would end up doing is you would have this. All right, let's see if this would work. So if I put a 200 there and minus x, let's see if that works. Okay, let's just say, for instance, that x is equal to 150. Okay, what you would have is you have your $20, and then this would end up being 200 minus 150, so that gives you $50. Isn't that what you want it to do? Yeah, okay. So same thing. Like if you talked for 180 minutes, you would want to put an 80 there. So if you did 200 minus 180, does that give you the leftover part like that? Okay. Because what you would have on that is if you have 180 minutes, then it needs to kind of then basically go like this then. So you'd have you already have your $20 there, and then what you would want to have on that is you would want to do 200 minus the 180 there. Hold on, that's not right. That would be back. I got that backwards there. So what you would end up having here is you would want this to end up being 80, okay, instead of that. So what do you do to get that 80? Well, what you would do is you would end up going 180 and then minus that, that 100 like that. That's how you do that. So what's going to go here, and you got to kind of think through this and play with it a little bit to figure this out, is what it looks like would go there is x would be the number of minutes you call minus 100 like that. Now let's see if this makes any sense if we do this. Okay, let's kind of play with this and make sure that this is working okay. All right, let's say that you have, so that thing would go away, 180, okay? Well, if you did that, that would be 180 minus 100, so that would be 80. Isn't that what you want it to do? Yeah. Is the extra 80 minutes times 0.075, okay? Let's try it one more time. You got to convince yourself. If you're a computer programmer, you got to figure out equations all the time. So let's say it was 190. Okay, you have your first 100. If you did 190 minus 100, that would give you your 90 left over. That's what you want, right? So that looks like that's working. Does that make sense? Okay, tell me if that makes sense. Okay, now what we're going to go ahead and do on this, though, is instead of putting this in your piecewise function, we're going to go ahead and we're going to multiply it out. Okay, so we're just going to multiply it out and collect like terms, so let's go ahead and do that then. Okay, so what I would end up having here then is that would be 20 plus 0.075x, and then if you distributed that like that, that would be plus 7.5. These are like terms, so if I put that together, that's a minus, and I just caught that. That's a minus there. Okay, then what I'd have is 20 minus 7.5 is going to be 12.5 plus 0.075x. So I'm going to have you in your piecewise function then write it like that. Okay? So that would be your second piece like that. Does that make sense? Tell me. Because these things can be a little tricky to figure out. You have to sometimes, I have to play with it a little bit to figure that out. So I'm going to erase that part right there. And then what we're going to look at from there is the last piece of this function is going to be what happens when x is greater than 200. Okay, well, let's think about what happens in this problem. Okay, basically what's going to happen in this problem is it's going to go like this. The first 100 is going to cost you $20. Okay, that's already set. The second 100 is going to be this. The second 100 is going to be 0.075 times 100. Okay, so if you talked for 200 minutes, you'd have the 20 for the first 100. Second 100 would be like that. Well, let's calculate that out and get that taken care of. So that's 20 plus, then that right there would end up being 7.5, like that, okay? But then we got one more thing we got to consider. The other thing we got to consider is what's going to happen once you get past the 200. Okay, and what's happening there? So once you get past that 200, then what's going to happen on that is you would end up having this. So now it's going to be 10 cents for everything that's past 200. Okay, so if I put x minus 200 there like that, let's see if that would work. That's your first 100. That's your second 100. Then this is the rest. Okay, so say for instance you had 250. Okay, what would happen? That would be 250 minus 200. So 50 minutes of that would be billed at 10 cents. Does that make sense? Okay, does that make sense? Okay, so you would have to multiply that all out and then put that together like that. Okay, so that's your first 100. That's your second 100, because that was 100 times 0.075. Then that's the rest. And what we're going to do is we're going to multiply that thing out. And when we do that, that should give us a simplified piece function. So that's 20 plus 7.5. This is 0.10x here. And then 0.10 times 200, if you work that out, would just be 20, like that. So that would cancel. So your last piece would be 7.5 plus 0.10x, like that. So if you were a computer programmer and you were writing the program, because the way any phone company would do this, so they just input the data and they get the answer. Okay, but that would be the mathematics behind the scenes in the program, is you would have to get those functions put together like that. And that works. So no matter what you plug in for x, that would give you the correct charge. Okay, tell me if that makes any sense. Sometimes that's kind of complicated for students. Okay, in my opinion, you got to kind of play with that a little bit in order to get that put together. Okay.